Now let us see a few questions and answers in image restoration. What is restoration? Restoration is a process of reconstructing or recovering an image that has been degraded by using a priori knowledge of the degradation phenomenon. Thus, restoration techniques are oriented towards modeling the degradation and applying the inverse process in order to recover the original image. So this is actually bottom up process rather than top down. So how a degradation process is modeled? Say a system operator H, which together with the additive white noise, say eta xy, operates on an input image fxy to produce a degraded image gxy. What is the homogeneity property and what is the significance of this property? Homogeneousness or homogeneity property is like this. This is K1, K comes out, H1 F1 X1 XY is equal to K1 HF XY, where this H is the operator, K1 is the constant, and Fxy is the input image, or F1 XY is the input image, F sub 1 XY. So it says that the response to a constant multiple for any input is equal to the response to that input multiplied by the same constant. So this is the homogeneity property. So this constant, if applied inside or outside of the operation, then also this is going to remain same. What is circulant matrix? A square matrix in which each row is a circular shift of the preceding row and the first row is a circular shift of the last row is called circulant matrix. For example, let me explain it to you again. This is a square matrix in which each row is a circular matrix of the preceding row. Means this row will be circulant of this will be circulant of this, and likewise, right? So here we see that this is the first row and we have this 0, 1 here. This is the circular matrix of the previous one. Now 1 here, 0 here means 1, this comes here circularly and this comes here, and likewise. So finally what we get is, we get H0 here and H minus 1 and M minus 1 here. So it's a circular matrix. What is the concept behind algebraic approach to restoration? Algebraic approach is the concept of seeking an estimate of denoted f cap that minimizes a predefined criteria of performance, where f is the image. So why the image is subjected to Wiener filtering? This method of filtering, Wiener filtering, considers image and noise as random process, and the objective is to find and estimate f cap of the uncorrupted image f such that the mean square error between them is minimized, so that image is subjected to Wiener filtering to minimize the error. So this mean square error is to be minimized. This is the criteria of Wiener filtering. Define spatial transformation. Spatial transformation is defined as the arrangement of pixels on an image plane. Rearrangement actually. Define gray level interpolation. Gray level interpolation deals with the assignment of gray levels to pixels in the spatially transformed image. Give one example of the principal source of noise. The principal source of noise in digital image arises from image acquisition, say digitization, or transmission. So the performance of imaging sensors is affected by a variety of factors, such as environment factors, conditions during image acquisition, and by the quality of sensing elements. So the factors are light levels and sensor temperature. These all factors, they actually add noise to the system. When does the degradation model satisfy a position invariant property? An operator having input relationship, output relationship like gxy is equal to, this is the h operator, and if we vary h for x, this will remain same to gx variation for any this fxy. and this variations, right? So this definition indicates that the response at any point in the image depends only on the value of the input at that point, not on its position. Why the restoration is called as unconstrained restoration? In the absence of any knowledge about the noise, right? And a meaningful criteria function is to seek an f cap such that this f cap approximates least square sense by assuming that noise term is as small as possible. Where this capital H is system operator, f cap is estimated input image, and G is the degraded image. What is the most frequent method to overcome the difficulty to formulate the spatial location of the pixels? The point is the most frequent method. This is the most frequent method, which are subsets of pixels whose location in the input, that is distorted, and the output corrected image is known precisely. What are the three methods of estimating the degradation function? We have observation, experimentation, and mathematical modeling. How the blur is removed caused by uniform linear motion. Now, an image fxy undergo planar motion in the x and y direction, and x0, x sub 0 t, y sub 0 t are the time varying components of motion. Now, the total exposure at any point of the recording medium, that is digital memory, is obtained by integrating the instantaneous exposure over the time during this interval, which the imaging system shutter was open. What is inverse filtering? Now, the simplest approach to restoration is direct inverse filtering, as estimated by this f cap of the transform of the original image, simply by dividing the transform of the degraded image by the degraded function. Degraded image by degraded function. Give the difference between enhancement and restoration. Enhancement technique is based primarily on the pleasing aspect it might present to the viewer. For example, contrast stretching, whereas this removal of the image blur, this is by applying a deblurring function is considered as the restoration technique. So, removal of image blur, for what this we apply restoration. That means we apply deblurring to remove the blur. This is restoration. Define the degradation phenomena. This phenomena, image restoration, degradation phenomena, the image restoration or degradation is a process that attempts to reconstruct or recover an image that has been degraded by using some clear knowledge of the degradation phenomena. So degradation may be in the form sensor noise, blur due to camera misfocus, relative object camera motion, etc. So what is unconstrained restoration? It is also known as least square error approach. To estimate the original image f cap, noise eta or n has to be minimized, and f cap is equal to g by h. What is blind image restoration? Degradation may be very difficult to measure or may be time varying in unpredictable manner. So in such cases, information about the degradation must be extracted from the observed image, either explicitly or implicitly. This task is called as blind image restoration. What are the two properties in linear operator? Additivity and homogeneity. Explain additivity property in linear operation or operator. If you apply this h to f1 xy plus f2 xy, you can apply it separately. This is additivity property in linear operator. What are the two methods of algebraic approach? Unconstrained restoration approach and constrained restoration approach. So what is meant by noise probability density function? The spatial noise descriptor is the statistical behavior of gray level values in the noise component of the model. So what are the types of noise models? We have Gaussian noise, Rayleigh noise, and Erlang noise. What is meant by least mean square filter? The limitation of inverse and pseudo-inverse filter is very sensitive to noise. So the Wiener filtering is a method of restoring the image in the presence of blur as well as the noise. Okay, so this is how this least mean square filter is. What are the two approaches for blind image restoration? It is direct measurement and indirect estimation. So this was a few basic questions of our image restoration. Thank you so much.